Hello, and welcome to today's webinar, Industry 4.0. Are you ready? With your presenter, AbuAli, adjunct faculty at University of Cincinnati and managing partner at IoTco. My name is Maria Ma, the marketing campaign coordinator for engineering.com, and I'll be your moderator today. First, a few housekeeping items to cover. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending this full live session, you'll receive a PDH certificate within 48 hours. If you have any questions, please submit directly in this webinar interface, and we'll try to address all questions during Q&A. Now, without further ado, I'll pass it over to our presenter. Mo, over to you.
Thank you so much, Maria, for the introduction, and good afternoon, good morning to everybody on the call. Thank you all for taking the time to being with us today. My name is AbuAli. I'm a managing partner at IoTco and an adjunct faculty member at the University of Cincinnati. And my organization provides digital transformation, education, training, predictive analytics, and IoT technologies and services. So we're in the business of digital transformation. We focus on the manufacturing sector, and we focus on how to use technologies to make factories smarter and to digitalize their operations toward their Industry 4.0 journey. So today, I want to discuss three things. I want to first set the stage on what is the Industrial Internet of Things. What is Industry 4.0? There's obviously a lot of jargon, a lot of namings, and I want to, in the beginning, put together some definitions which make sense for the folks on the call today. I then want to talk about digital tools of the trade. If you want to digitalize your operation, if you want to go through Industry 4.0, what are the tools of the trade? How do you get connected? How do you capture real-time metrics? How can you use industrial AI and predictive analytics to drive towards better uptime and better quality for your operation? But before going deeper, I actually have a poll question. And my poll question is around, where are you today in your Industry 4.0 journey from level 1 to level 5? So Maria, I appreciate if we can show the poll question to the audience before we start.
Thanks, Mo. Audience, please let us know. How would you rate your experience implementing Industry 4.0 tools and technologies in your workplace? 1, still learning about Industry 4.0. 2, getting started with a pilot. 3, implemented a pilot without success. 4, implemented a pilot proceeding to scale. Or 5, you've been there, done that. We'll give you a moment to respond. A few more seconds. Looks like we have at a whopping 74% still learning about Industry 4.0. 13% said they're getting started with a pilot, and 7% said implemented a pilot and proceeding to scale. Thanks so much. Mo, back to you.
Thank you so much, Maria. I'm pleased to hear the results, actually, because the presentation that we're going to go over today should hopefully help those 74% of the folks that are looking to learn more about Industry 4.0, and hopefully give you the opportunity to start getting into pilot mode with Industry 4.0. So let's start. The first topic is, what is the stage here? What is the Industrial Internet of Things, and what is Industry 4.0? So the field of IoT, Internet of Things, is actually a very holistic field. It includes all industries, all things, and all devices. And in all honesty, this is not a new field. Critical and safety functions and products like jet engines flying in the sky and power plants and nuclear operations, they have been monitored and they've been collecting data for decades, okay? But now with the faster computational speeds and reduced cost of sensors and hardware and cloud storage. All these characteristics have accelerated the adoption of IoT beyond the safety critical industries into manufacturing and non-manufacturing verticals. So the industrial Internet of Things, or IIoT specifically, is all about implementing IoT within the manufacturing or within the industrial space. And when you look at a factory today, from the IT stack within the factory, there is usually 4 layers that are presented within any operation. You have your machine layer that you see right there, your CNC controls, your PLC controls, your sensors on the factory floor, and that usually requires a data acquisition system to capture data from the machine layer and present it to the operators using an HMI, using a human machine interface. And you can see the abbreviations on the left there. In some manufacturing operations, there is an MES system, a manufacturing execution system, which is tying the factory floor to the top floor, which is your business system, your enterprise resource planning solution, which does your finance, your inventory, your warehousing, and production orders, and so on. The fact is, in many situations, those layers may not exist, especially the middle 2 layer, the SCADA and the MES. And in some cases, they do exist, but they're fragmented. They're not connected to each other. They are siloed. So Industry 4.0 is an initiative to drive the adoption of the industrial Internet of Things. And it's all about the convergence between IT, which is your ERP, your top financial and business systems, to the OT, the operational technology, your machines and your parts on the factory floor. And this IT-OT convergence is not an easy task. And there's a lot of challenges behind it, which we're gonna briefly address here during the presentation and address how they can be mitigated. So when we look at and summarize a digital transformation strategy to support industries to go into the Industry 4.0 era, we're usually looking at 4 key characteristics of that strategy. The first one is technology. What is my technology selection? What is my infrastructure requirements? What's the architecture like? I have a single manufacturing plant, whereas I have 50 manufacturing plants in 3 geographies, right? So how can we select the right technology for our business? Second is the type of analytics that is required to run the business. We'll talk about performance analytics, which are historical information about the performance of the manufacturing plant. But we'll also talk about predictive analytics, which is the use of Industry 4.0 tools like artificial intelligence to predict future issues on the factory floor. And to make all this happen, connectivity is required, right? We're actually going to start to talk about connectivity first, because real-time data is required to ensure that your analytics and technologies are running in the proper way. And last but not least, what's the return on investment? One of the biggest challenges in implementing Industry 4.0 today is actually the ROI and the business justification of implementing it. So there are approaches to make that implementation financially justifiable for the business. So that's IoT, that's industrial IoT, that's Industry 4.0 as an initiative to realize that, and those are the 4 pillars to support Industry 4.0 strategy. So Industry 4.0 was actually a German-born initiative. That initiative was a collaboration with the Fraunhofer Institute in Germany and some prominent industries there, which grew to become a European and a global initiative. And in the North America, actually, in the United States, NAM, N-A-M, the National Association of Manufacturers, has a manufacturing 4.0 equivalent of Industry 4.0, which is very focused on implementing these technologies into manufacturing. So NAM is a great thought leader in this area, actually, the National Association of Manufacturers. But Industry 4.0 is about the digital connected world. It's about using the internet, it's about using the cloud, it's about using key technologies to capture real-time data from operations and help those operations create what's sometimes called a digital twin of their plant. Okay, so in Germany or in the Industry 4.0 world, there's a term which is a cyber physical system. Cyber is your IT world. Physical are the actual physical assets on the factory floor. So by mirroring and connecting those physical assets to the IT landscape, you have a cyber physical system or a digital twin of your operation that you can use to understand your operation better and to improve your operation over time. But I actually have a very simple definition of Industry 4.0 I'd like to show you. Industry 4.0 is actually all about combining the traditional manufacturing practices of today with the technological world. And there's actually a strategy behind it. There are challenges, but there's also countermeasures, and there are digital tools that could be implemented depending on the digital maturity of the organization. So let's talk about that. First of all, why is it accelerating? When we look at the supply chains are becoming increasingly complex. Okay, if you take a company like Boeing, for example, Boeing has tens of thousands of suppliers that are actually making parts that end up going into a Boeing airplane, for example. So thousands of parts and thousands of suppliers need to be managed to make a single final product to be assembled by Boeing. That is a reason for the start to adopt technologies on the factory floor, because product and volumes and mixes are changing. You have factories that are running high mix operations. Some factories are low mix, high volume operations, always making the same part, like in the automotive industry, extremely repetitive, okay? And at the same time, when you look at software and hardware systems, they're actually becoming cheaper. Cloud storage is becoming cheaper. RAM is becoming cheaper. CPU power is becoming cheaper. Not to mention sensors and hardware are actually becoming cheaper. A vibration sensor 10 years ago was maybe $1,000 to $2,000. Today, it's about $250 for a vibration sensor on a machine. Or if you have a legacy machine on the factory floor, it's about $300. Just imagine, for $300, you can connect a gateway hardware to an old machine and you can capture real-time data from that machine. So what does all that mean? All that means there is opportunities for manufacturers today to have a very cost-effective approach to generate revenue and to be a winner in an increasingly complex global ecosystem. But while it is accelerating, there are challenges, there are barriers, and barriers are opportunities to be thinking about how to improve. The first barrier is actually IT systems. The automation pyramid that I showed, it is not easy to find a company that has, a brand new IT system and a brand new infrastructure. Unfortunately, some of those solutions in the pyramid are siloed. They're not connected to each other. They are older. There are ERP systems that are called the green screen ERP systems that are still running on the factory floor, and they're running and doing a good job actually, but they are too outdated and they do not communicate with other systems. Then you have the same issue on the OT layer, on the operation layer on the factory floor. You have old equipment. They're dumb equipment, but they're very capable equipment. Unfortunately, they don't have Ethernet ports and they do not communicate to the outside world, right? This is where there is cost-effective hardware methods, as I mentioned, that could connect and capture data from these antiquated systems. Then people, right? Workforce. There is new skill sets required. There is aging workforce that has significant knowledge that is actually graduating and retiring, right? I was surprised to know that the average age in the aerospace industry of a machinist, an operator running a machine, the average age is about 60 years old. Imagine that. The average age of a machinist, a senior machinist on an aerospace factory floor making jet engines that go on your plane, is about 60 years old. So when this person, he or she, retires in 5 to 10 years, significant tribal knowledge is lost, unfortunately. But at the same time, there is digital natives. There are youngsters, millennials, Gen X's that are going into industry. They're extremely tech savvy, right? So how can you start balancing the outgoing retiring workforce and the incoming digital natives, right, that are coming into the workforce. And then new processes, right? Every time you implement technology on a factory floor, technology is actually the easy part, but the people and the processes to ensure that this technology becomes ingrained and entrenched into the people by having an intuitive way to use the technology, a human-machine interface that enables ease of use, right? Just like you have an iPhone, you have apps on your iPhone that you use because they're easy to use and they'll help you do your work. There's also a similar approach to do this in manufacturing. And I put this at the bottom of the list actually because I'm a believer in ROI and justification of these things. If there is a proper balance between people, technology, and process, funding and ROI justification should not be an issue for the organization. And it is not just about technology. Technology is actually, in many cases, easy to implement, and the software will always work. But the key barriers are sometimes within the process of implementation and the people and the change management that you have to put in place to make sure that the Industry 4.0 implementation is successful. So people, process, technology is a recipe for success and a recipe from being profitable and generating an ROI with any Industry 4.0 implementation. So think about this for a second, right? If you work in a manufacturing company today, or if you plan to work in a manufacturing company, what is your maturity level, right? What is your digital maturity? What is your Industry 4.0 maturity? If an organization is still working towards getting connected and trying to put the machines on the network and trying to capture real-time data, this is still an Industry 3.0 era of automation, right? So I want to connect my manufacturing floor. I want to capture real-time data from my floor. I want to transition now from an Industry 3.0, which is more of a reactive standalone mode of doing manufacturing, into an Industry 4.0 era of an organization. And by doing this, I want to embrace becoming a smart factory. I want to capture real-time data from my factory floor. I want to capture metrics that we're going to talk about. An example of those metrics is OEE, overall equipment effectiveness. I want to start looking at maintenance and quality and energy on my factory floor, right? So taking this up a notch, if I have multiple plants within my organization, I want to start integrating my manufacturing network, right? I want to have multiple smarter factories. I want to do multi-site benchmarking of my operations. I want to look at the performance over multiple sites around the world, and I want to understand what are the gaps and where can I improve, right? So that's a next level of maturity within your Industry 4.0 journey, to have an integrated manufacturing network and multiple sites that are actually adopting Industry 4.0 technologies. So now you start looking outside your operation. You start looking at your supply chain, right? Your suppliers. You start looking at your end customers, and you start collaborating with them. You start using technology to integrate your existing manufacturing company with the suppliers that are providing you parts, or with your end customer whom you are providing parts. Starting to adopt predictive analytics and prescriptive analytics and cognitive analytics. We'll talk about all that, right? And having new business models and new approaches to improve your customer satisfaction and to improve your supply chain integration and satisfaction. So think about where you are today, right? Your manufacturing operation. Are you still in an Industry 3.0 setting and you're working out the strategy to improve, and maybe you're in a learning mode? Or have you embarked on a smart factory journey, whether you're doing it for your plant alone or whether you're starting to go beyond your four walls and even going into your supply chain and your end customer base? And the reason I'm showing this is it is important to understand your maturity level. It is important to come to terms and agree, what is your baseline? Where are you today? And based on knowing where you are in those different levels here, you can start implementing technologies that make sense for your organization, and you can start looking at the roadmap elements required, the people, process, technology, and where is the best place within your company or even within your factory, which department should you embark and implement Industry 4.0. And before looking at the tools, I think it's always important to start with the business case first, okay? Technology comes second. Business case and a baseline understanding of your maturity and your business needs in the short term and the long term is a key driver and the catalyst to any future success that you're going to have with Industry 4.0. So what are your metrics, right? What is the why for your business? WHY. What is your why? Are you measuring OEE today? How do you measure it? How can you improve labor productivity on your factory floor? By becoming less paper oriented and more paperless on the factory floor. Implementing predictive maintenance, right? Driving towards a zero downtime operation is not easy. You need to mitigate unplanned downtime. You need to even link with your maintenance system. You need to reduce spare parts. You need to optimize your mean time between failure, mean time to repair, which are key metrics for the maintenance organization. You need to schedule spare parts and schedule labor before the machine even fails. You want to transform your mindset and your operation from a fail and fix mode of working, and in some cases firefighting, to a predictive and preventive and prescriptive mode of operation. So what is the why, right? And the why could be different even within one plant. You might have a section of the factory that is doing robotics, for example, where uptime is more critical for your business. You might have a section of your factory where you're doing casting and injection molding, and quality is more important for your business, right? So understanding your why and doing a criticality analysis, doing a maturity assessment of your operation is the first step towards moving from an Industry 3.0 to an Industry 4.0 and starting that zero downtime, zero defect journey towards the future. So now that we've kind of set the stage for what's happening out there, I want to introduce some key digital tools of the trade, starting from maybe the lowest level of maturity up to the highest level of maturity, to support any organization at any level of maturity, actually, to embark and get moving into the Industry 4.0 journey. And this is just a reminder, if anyone has any questions, just please drop them in to the chat or the Q&A section, and we'll surely get them addressed during the last 15 minutes of the session today. So let's start with tools of the trade. You know, there's a lot of tools out there, but I went ahead and summarized some of the key ones for the conversation today. And the first one, number one, is actually getting connected and capturing real-time data from the factory floor. And I cannot stop to just stress that this is key for the business. If you cannot measure it, you cannot improve it. And also, if you cannot measure it in real time, you cannot improve it in real time. Real-time data is key to drive the business. And now once you have data, what do you do with the data? How can you take that data and represent that data and have transparency and visibility and have performance analytics to run your business with? Moving into execution, how can you execute from the OT layer to the IT layer of that automation pyramid, right? So what do you need to do around production, inventory, traceability, quality, maintenance to drive your maturity level higher within your operation? And then going into the use of industrial artificial intelligence and AI to start looking at data from a different view, right? Applying data science on the data and going towards predicting future maintenance issues on machines before they happen, or even predicting that you're going to make a bad part, a defect on the machine before you make a bad part. Imagine that, right? You can start to do prescriptive analytics on the factory floor and truly have a lights out operation that's driving you towards minimum downtime and minimum quality issues. And it all starts with education, actually. And we'll talk about the academy and the education we're doing at the University of Cincinnati at the end of the presentation today. So number one, get connected. Manufacturing data is the foundation. And two words are missing, actually. Real-time manufacturing data is the foundation. Some say data is the new oil, actually. And it's very important to honor the value of data alongside the people and the expensive capital that you have on the factory floor, right? We invest so much in our people. We invest in buying new machinery, the better machinery, better controls, better precision. But actually, without data coming from the people and from the machines, it is difficult to run the operation and difficult to run continuous improvement programs in a meaningful fashion. So these are some of the questions we ask. It's important to assess the readiness of your plant to get connected. And there is a systematic process that you can do it with, by the way. There is an opportunity to audit the operation and understand the maturity of the assets that you have. And focus on the critical assets, right? Focus on the most expensive assets or the assets that are making the most expensive or critical manufactured parts for your business with the key clients for your business. Not all assets are critical to the business. Some assets are there because of redundancies that are built in and so on. So evaluate the readiness of your factory floor to be connected and to become Industry 4.0 enabled. And how do you do that? There are several steps. The first step is, is my machine even network capable, right? Does the machine have an Ethernet port? Or does it have a serial port? Or how do I talk to this machine? And be rest assured that there is technology out there and there is hardware out there where you can use low-cost industrial-graded hardware, $300 or $400 for a machine, to actually sensorize and capture data in a very affordable way. And then connect the machine to the network. There is an IT networking and infrastructure conversation to be had and things to be aware of, like cybersecurity, and some of these things are also critical to be included in this audit. And then what is the data map? What are you trying to achieve, right? What type of data do you need to capture from the machine? In many cases, there's a lot of data available, but it's important to collect the right data map that makes sense for, again, the business case that you're trying to solve as a company, whether it's uptime related, quality related, or other issues that you're trying to solve. The last but not least is making the data available, okay? And there's a lot of systems out there. There are systems that use languages, common protocols, machine protocols, which can speak to any other system. There is a language called OPC, for example, OPC UA, Unified Architecture. There is a CNC machining language called MT Connect by the Association of Manufacturing Technology, AMT. So there's a variety of ways now that machines are able to speak, just like I'm speaking here to the audience, in different languages, right? And each machine speaks a language, and those languages can be aggregated together in a database or in a data lake. And that data lake is your source, your single source of truth for any other system that you're going to end up putting in place to support your company. And this is a good example here, actually. What is my data map, right? Do I need to collect quality data or process data or attribute data? Or do I need to trace my parts? There's a lot of regulatory compliance happening in aerospace, automotive, pharmaceutical, and traceability of parts is very important for the business, right? So that's another data type that may need to be captured. But in some cases, I'm just capturing data to understand the machine uptime or the machine performance, right? Is my machine running? Is it down? And if it's down, what's the reason, right? And in many cases, the machine can provide you that information without the need of an operator or a person actually writing it manually on paper. And then how do you make the data available, right? As I mentioned, there's multiple ways to do that. I would say the top solutions in the market right now include an OPC historian, which is called Kepware. It's a PTC product that was an acquisition by PTC. It's a very affordable solution, actually, with over 100 different drivers. So just imagine it speaks 100 different languages that can talk to 100 different types of machines out there in the world, right? So if that machine is on the network, an OPC historian has data available or drivers available that would immediately just pull data and configure directly. And then now that you have the data, you can represent that data to other systems, your maintenance system, your predictive system, your manufacturing execution system. It's a single source of truth, one repository, one data lake to drive operational improvements in your business. Real-time data delivers real-time analytics and real-time metrics that you can trust and rely on to actually run your business, improve, and go into your Industry 4.0 journey. So we always talk about two types of metrics. The first one is performance, understanding historically how you're doing today and how you've been doing in the past weeks and months. And these metrics are scalable, right? I can look at my stamping department in my factory. I can look at my whole plant, or I can look at plant versus plant, right? But performance metrics are good at telling you what's happening now and historically, whereas predictive metrics start using advanced analytics and AI and machine learning to convert that data into asset health. Is my asset really healthy to continue running making parts? What's the prediction? When is this asset going to fail before it actually fails? So I can have a window to act, right? To order a spare part, to call a maintenance person to fix the machine, rather than firefighting, rather than running overhead maintenance over the weekends, which is obviously cost for the business. So in today's world, every company measures productivity on the factory floor, right? How many parts have I produced, and what is the dollar figure of the parts that I've produced? But it's important to go underneath the surface, right? To unleash the hidden factory, we say sometimes, because the hidden factory is not just productivity, it is the metrics that are leading to the productivity improvement or productivity loss. That's the underlying factor. And those digital metrics come with the digitalization and the real-time connectivity to the factory floor. So OEE, your utilization, right? How long has the machine really been running? And why has the machine been down, right? What's the true uptime of my assets? Companies invest so much in the assets on the factory floor. You have expensive millions of dollars spent on costly equipment. But when you look at the uptime of the equipment, you sometimes say, hey, wow, I bought all these machines, but the uptime in my factory is like 80%. So why aren't those machines running best in class, 85, 90%? Why is there a gap? And in order to understand that gap, and in order to get a return on the expensive capital you have employed on a factory floor, you need to connect to the equipment and you need to understand truly what is the uptime and what is the reason for failures. Then you have performance. How fast are you making your parts? When you manufacture a part on a machine, that part takes time. It might take, let's say, 15 seconds in a high volume environment, right? But are you really producing to 15 seconds? Or has it taken you 10 seconds, or worse, 30 seconds to produce that part? So performance is that comparison of your standard cycle time and your actual cycle time, which requires connectivity in order to give you that information in an accurate manner, right? And then quality. I'm producing parts, but how much scrap did I make? How much rework parts did I make? And what is the reason for scrap, and what is the reason for rework? And going deeper into quality characteristics of the data, the dimensions, the tolerances, right? So availability, performance, quality are three key underlying metrics that need to be measured in order to measure metrics like OEE and to support an understanding of productivity improvements or productivity losses. So now I've collected data, and now I've converted that data into a representation of key metrics like OEE, and then later we'll come into the predictive metrics as well. And then it's important to visualize transparently those metrics to the manufacturing floor, okay? The right information to the right person at the right time. The plant manager versus the maintenance engineer versus the industrial engineer versus the cell production manager, right? You cannot paralyze people with too much data and too much metrics. They would cease to use those systems because it's paralyzing them with too much data. They're unable to act, right? Data analysis paralysis. So the question now is, I have that data and I have the metrics, but who should I send the right data and the right metrics to the right person at the right time? So it's important to select and implement systems in organizations that allows them, for example, to log in as a plant manager. I'm a plant manager, and I could immediately see my factory. I could immediately see my KPIs in a visual, color-coded manner, right? Availability, performance, quality. Without me even explaining such a screenshot, anybody on the call today will be able to look at it and understand that how's my factory doing? Not good today, actually. 49%. What's happening? I've produced 42 pieces. I'm supposed to produce 200. I'm way behind. What is the reason for that, right? Here's my hour-by-hour chart, which, by the way, comes from real-time data from the machine. Red is my target throughput. I got to follow red here, the red line, in order to complete a productive shift. But unfortunately, I was not able to do that because there was a big gap. So what is the reason for the gap? Oh, I had a reverse roller failure here. I had a roller jam failure here. I had a big product change, which took time. I even had an unknown downtime. Why do I not know the reason for this downtime here? Let's investigate, right? So this becomes an input to the continuous improvement team within the organization, so they can start running their daily meetings, right? And leveraging this Industry 4.0 technology to ramp up productivity for their business. So now I'm collecting data. Now I'm looking at metrics. My people are using my metrics. What else can I do? Well, hey, congratulations. You've started your Industry 4.0 journey, and you're looking at some key production operations features right now. You're looking at OEE, you're looking at downtime, you're counting your pieces, you're counting waste, you're doing some scheduling in an intelligent way. Everything is electronic. There is less paper on the factory floor. Clap, clap, great stuff. But how about your inventory? My customers now need traceability. I want to know the birth certificate of my part, right? Every operation my part has gone through. I want an electronic digital record of everything my part has gone through, all the way until the part became a door panel, and then the door panel went on my Toyota or BMW vehicle, right? Because if there's an issue and the passengers call the dealer, they need to trace it all the way back to manufacturing. They need to know this door panel was running in the factory in Cincinnati. It was running on machine X, and John Smith was running it, and there was a problem with the torque on the gun, right, when you produce the part. This is all traceability, guys. This is backward traceability, forward traceability, and the ability to understand truly what happened to your part. So that's inventory operations. And then quality operations. I need to do checks on my part. I need to do statistical process control to make sure my variables are within tolerance, right? I need to do process monitoring. If the temperature in the mold of my injection molding machine goes out of whack, it's not good for my business. I need to control that, right? It has to be within my upper spec limit and my lower spec limit. And then now I want to do maintenance for my assets, which will bring us into the last piece, the last digital tool around predictive maintenance. But first, you need a standard maintenance ecosystem to be in place, right? You need to have standard operating procedures to maintain your machines, to record spare parts, to record repairs, to manage your tools. So my message here is Industry 4.0 is not just about collecting data and visualizing them green, yellow, red on a nice screen or even on your cell phone. It's about understanding what is the needs of the business, right? What do I need to do in the short term? What do I need to do in the long term to have better relationships with my internal factory people and my external clients and my external supply chain, right? And therefore, a strategy around Industry 4.0 must revolve around multiple areas, and some of those areas you see here. And that now brings us to implementing industrial AI on the factory floor, because I have a data lake now. I've collected the data, right? I'm using it for metrics and all that. But now I want to do more with the data. I want to implement artificial intelligence and machine learning to transform that data into smarter data around maintenance needs and quality needs of my process. I want to have a worry-free manufacturing operation by driving towards zero downtime and zero defect in my plant. So how do I do that, right? There's actually a systematic approach behind it that has been well studied for many years. The University of Cincinnati is a great example, actually. The Center for Intelligent Maintenance Systems, IMS, where I graduated many years ago, has focused on this for many, many years and has actually spun off companies and graduated many intelligent PhDs and master's level students that focus on implementing predictive analytics in manufacturing, actually. So the Center of IMS at the University of Cincinnati has been great in doing that. And it's all about a systematic process of taking data and applying an analytics workflow to it, like a recipe, from signals to applying the machine learning techniques to extract features, which are metrics that are statistically indicating your data. And then the features are used to train machine learning models, which provide health prediction and diagnostics for your asset, for your key asset. Some of these models are what's called unsupervised learning. I do not have historical data, so I train the models from scratch, right? And I need baseline data, and then I run the models. But in some cases, it is supervised learning, where I actually have a signature of previous historical data of a good machine condition and a bad machine condition, which can be used to train the machine learning models, right? Then you have predictions offering accuracy, right? Every prediction has an accuracy, and you have to rely on that accuracy when you start scheduling maintenance and scheduling spare parts in your Industry 4.0 journey. Also, it's important to understand that there is a variety of equipment out there, right? I'm going to show two quick examples, but robotics, CNC machines, casting, molding, stamping, and the ancillary components that surround the manufacturing operation are very critical assets to the business. In many cases, they're not just uptime critical, but they're quality critical. They're mission critical. So it's important to understand your critical equipment and then to understand what type of data and how to get connected to those equipment, and then implementing the ML analytics. So you come up with what I call templates. Those templates allow you to walk into your factory and implement an AI solution in weeks, not months and years, right? It is not an R&D project anymore. You're in a live working condition. You have to use domain knowledge, and you have to use data science techniques that have been proven and implemented, and then actually implement such templates to run and to train the models, to validate, to baseline, to go live and train your customers within a short period of time, so that it is meaningful to your business from an ROI perspective. Two quick examples. First, industrial robots, right? I think the message here is predictive maintenance will not solve all the problems for your business, okay? It's important to understand that it's there to complement your PM system, your preventive maintenance, right? You got cables that fail on the robot, you have dead batteries that go wrong. Predictive maintenance will never catch that, but predictive maintenance will help you catch, like the 80-20 rule, right? 20% of the issues may cause 80% of the downtime on your machine. So by mitigating the things in red right here, the worn belts, the gear backlashes, the bearing failures when you monitor the different axes of the robot, that could probably help you capture 80% of the big critical issues that happen in your plant. So it's important to implement those solutions, keeping in mind that you have multiple robot manufacturers with multiple ages of equipment, and that data needs to be received from a PLC controller. So there are algorithms today that can take the torque data, which is the current signal from each axis of a robot, and with about 2 to 4 weeks of baseline data, start to provide you reliable predictions, usually a few weeks in advance, of when an axis of a robot is actually going to go bad before it goes bad. So you can order spare parts and schedule maintenance very quickly, and not have to find ways to do it after the fact when the robot axis actually went down, and then the whole line stops, and then you're not making parts, and then it's a significant loss for the business. And this is just an example of the representation, okay? And my message here is those solutions, end users, are the maintenance organization. We have to keep in mind that those end users are not PhDs. They are not data scientists, okay? We have to build those solutions in an intuitive way so that a maintenance engineer who is very good at fixing machines can look at this data without being a data scientist and immediately understand that my machine is healthy, right? It's close to the baseline. My machine has degraded, and here's my prediction. So yeah, I need a, schedule a predictive ticket right here, a work order, so I can fix the machine before it fails. And here's the reason for failure. It's axis number 5 on the robot. So I actually don't need to go and fix all the 6 axes as I've probably been doing the past weeks. I just need to go spend time on axis number 5 and fix that axis within the next 2 weeks. And this will ensure that the robot continues running with the maximum level of uptime and producing good parts for the factory floor. So always think of your end user, okay? Do not design systems for folks just like yourself. I'm a PhD, I design systems that could be read by other PhDs. This is not the case in Industry 4.0. Human-machine interfaces are key. They have to be intuitive. Design it for the user. A user-centric design will make very complex analytics actually become very simple for the end user to adopt and to use in their daily lives. Another quick example, smart machines. So many moving parts. You have tools, you have spindle bearings, you have a coolant system, you have a linear axis. But it's the same concept. What is critical for your business? Think big, start small. Let's say spindle bearing is the biggest issue on my CNC machine due to uptime, due to quality. And then understand your data model, right? I need vibration data. I need to capture motor current and spindle speed directly from my CNC control. And I need to design it for the user. It has to be user intuitive, right? The user has to see the status. The user has to track it over time. The user will see a diagnosis right at the bottom here. In this case, I'm looking at a bearing. So my AI is actually predicting the specific harmonics of the bearing using vibration that are leading to the failure. So there's an 8 kilohertz band frequency here, or to the right of it, there's an outer race failure on the bearing, which may be leading to the failure on this bearing, right? So with this type of component level analytics, you can go very deep, and from the depth of the analysis, you can understand not just which area of the machine is going to fail, but what is the actual reason for failure. So I'm gonna go ahead now and go to the last piece actually of my presentation. And please start typing your questions. Glad to address them in the few minutes we have left. I think my summary is very simple actually. A lot of content was shared today. I hope it was valuable for the audience. What I've shown here in an hour or less is actually a complete course that we did at the University of Cincinnati that took 7 weeks, but it was basically a summary of that course. So I hope it gave you at least some nuggets of areas that could support you in your learning. And also some of the folks that we polled earlier, they said they're piloting some of these solutions. It might help you improve what you're doing today. But there is a systematic approach to transform using Industry 4.0. And this is a great summary slide. It starts with an assessment. Assess your maturity level, right? Where should I start? What is my business case? Go into a workshop, education, training, learn. People, process, technology are your key recipes that you have to bring together and do a gap analysis and then understand what the future can look like for your company. And then implement a proof of value, okay? A proof of value has a business case and a technology implementation. And it shouldn't take long, actually. I like to say it's a 1, 2, 3 process. Assess, workshop, and never run a pilot beyond 90 days, all right? If you're not seeing technical and business value within 90 days of running an Industry 4.0 pilot, there is something wrong. It's either people, process, or technology. And you have to have a lessons learned, you have to pivot, and you have to find another set of people, process, technologies that may make sense for your business, okay? And then scale, train your internal center of excellence, find the talent that's needed to do it, partner with the right companies in your journey, and you'll be very successful in scaling those solutions. Short summary, think big, start small, but act now because it's becoming a very competitive market. And it's critical to be staying competitive and to sustain your operations that you embrace Industry 4.0 and you start acting towards the future. Start with a proof of value. Business plus technology equals proof of value. These are not proof of concepts any longer. The technologies are there. You just have to put the technology with the right people and the right process, and you will be successful. Whether you run a smart factory where the vision is downtime and defect reduction, or whether you have smart connected products. Maybe in a future webinar, we can talk about using analytics to actually create new business models for your smart products. That's a completely open domain right now that is using analytics actually to create new business models for your end customers. And always identify your weak link and ensure that you start those pilots at the right place within your organization where people, process, technology are the recipe for success in your business. So we have at least 10 minutes, 12 minutes for questions. If you'd like a copy of this presentation, please shoot me an email or connect with me on LinkedIn, AbuAli at IoTco.com. And I want to thank the University of Cincinnati and engineering.com for hosting this webinar today. And I think I'd like to open it up for questions. Back to you, Maria.
Awesome. Thanks so much, Mo. That was great. We do have quite a few questions in a queue here. Our first question is, how could you connect old equipment which has DOS-based software? There are no ports to connect with the internet. How can we get the IoT implement on this type of equipment?
It's a good question. We have to study the equipment. There's always ways. When it comes to proprietary equipment, there may be a need to create a new driver, or if the machine is Ethernet capable. If the machine is not Ethernet capable, we have to instrument the machine with the gateway hardware and sensors if required. But my view is, if the machine is Ethernet capable, there is usually a way. And if the machine is not using a gateway hardware or a sensor, an add-on sensor can be done in a cost-competitive way, and it will definitely provide you the information you need. We've worked with a lot of proprietary machines in the past, and there's just a little bit of discovery and a little bit of due diligence that has to be done. Feel free to email me if you want a link regarding the machine and what it does, and I might have some ideas for you.
Perfect. Thank you. Next question. There is a cryptocurrency focused on the Internet of Things, IoTA. In general terms, does putting cost/value on the data incentivize Industry 4.0?
I think that is a philosophy, especially when it comes to smart connected products. I have not talked about that today, but we have many clients who sensorize their products in the field, whether they make pumps or gearboxes or other approaches, and they use that data and they charge for that data so that their end users can receive better warranties, better remote monitoring services, or even use the data to improve future designs of their products, to enhance design. So I think there's definitely a play of monetizing data when it comes to smart connected products.
Great, thank you. Next question. This attendee would like to see some sort of one slider for an example where both AI, machine learning, predictive analytics, IoT, and big data principles are used to streamline Industry 4.0 technology and to show how they are interacting together to get the best performance possible in the new factory. Where would you suggest they could find some information like this?
I think we have some case studies. We would call such a project a digital transformation initiative because it is multifaceted and it has multiple data sources that are used in multiple ways, from metrics to execution to AI to analytics. Happy to provide you some of that information if you get in touch with me. It is not covered in the presentation here, and I also have some architecture slides on how you can technically architect those solutions from the sensor to the data to the execution to the analytics. But you ask a very good question. There is definitely architecture and use cases available that show multiple digital tools for Industry 4.0 used in one slide.
Perfect. Thank you. Next question. When making a business case, how does one estimate the cost to maintain all of the hardware, software, labor, etc., to support Industry 4.0 initiatives?
It's a good question, and you started to answer your own question, actually. Those are the key line items that need to be part of the justification. You need to look at one-time costs and recurring costs. And in many cases, the software will be recurring because usually it is a subscription cost. You would need to look at the cost of the hardware, the cost of the implementation services, and the cost of your, what I call internal costs, which is your IT infrastructure costs. And there is multiple drill downs right under that. So external costs, internal costs, and then looking at one-time versus recurring, and then dividing it up into proof of value, which is pilot costs, and also rollout costs. So there is multiple dimensions to an ROI justification, and happy to maybe talk to you offline about that, because then you would need to take those cost numbers and you would need to compare them to uptime improvement, quality improvement, some ROI, right, in order to calculate what's your ROI percentage. And we've worked with clients actually on ROI calculators in the past, depending on the use case, and those calculators can be standardized for the business and to support you to understand costs now and costs in the future.
Awesome, thank you. Our next question starts with, first, a well done webinar, Mo. And
Thanks.
goes on to say, there is a lot of the manufacturing end that can be connected to the front end design of either the part you are making or the machine you are designing. Why is there rework and rejection of parts? Why is a cable failing in a robot? Is this a design failure? So info has to get back to the design engineering folks too. So there is connectivity to a PLM system too. Am I correct?
Yeah, it's a great question. I focus my effort today on manufacturing because I think solving manufacturing issues is usually the quickest win. This is where the biggest problems lie and the biggest ROI can be achieved. But some of the questions you asked right there are more pertaining to what I would call the digital thread, from design to manufacturing to aftermarket services, right? And there is definitely a role for IoT and Industry 4.0 along the whole digital thread. And you can take manufacturing data and you can feed it back to design to improve design. You can take it and feed it forward. You can feed it backward. You can take data from the field and feed it back to manufacturing and feed it back to design, right? So digital thread is an important concept that takes what I showed today and goes beyond. But I fully echo what you said, right? One comment I want to make though is things fail, right? Things fail by characteristic, and everything has a life. And the idea is always how to elongate that life, right? So you can continue running it with maximum uptime, making parts with the best level of quality, but keeping in mind things will fail, and also keeping in mind AI and analytics can capture some failures and will not capture other failures. But having all this clearly defined and understood by everyone and documented allows you to run your operation in a truly zero downtime, zero defect manner.
Perfect, thank you. Next also starts with a comment. This is one of the greatest presentations I have seen so far covering Industry 4.0. Thanks for that.
Thank you so much. I hope next time we do a poll, Maria, that the 74% becomes, we should do this again in like 6 months, then the 74% becomes maybe 20%, doing pilots this time.
Yeah. So the question is, how do you see the importance of lean principles as part of the maturity assessment? Is it of an equal level of importance of IT/connectivity infrastructure?
This is a great question. Actually, we just published a blog and you can see it on our LinkedIn. It's called 6 Steps Towards the Factory of the Future. And the first step is actually lean manufacturing is the foundation, okay? You will not be successful implementing technology without having a solid lean foundation. 5S, Kaizen, sort, shine, sustain, standardize. When I worked at Toyota 16 years ago, Toyota Production System, that's all we preached. And that strengthens people and process components of the recipe within manufacturing. And then adopting technology becomes very easy for the organization, actually. So I fully echo the question. Lean manufacturing and having an ROI mindset of maximizing uptime, reducing waste is all about zero downtime, zero defect, plus the technologies that are available in the market today.
Awesome, thank you. Next question. What sort of certifications are available for Industry 4.0 at the technician and engineering levels?
It's a great question. Actually, this is why we partnered with the University of Cincinnati, and University of Cincinnati started the 7-session Industry 4.0 course that was given a few weeks back. Very successful. We had a class of 70 students, and what I showed in an hour, they went through for 7 weeks. We graduated them, and they are now Industry 4.0 practitioners working in their companies. I do believe we plan to do this class at least once a year with the University of Cincinnati, maybe even more down the road. But I think what the University of Cincinnati did was a great example, actually, of what other universities may start to be doing, whether it's community colleges or whether it's universities like UC. I suggest you check out the UC course and get in touch with me. I might have some ideas also of what some societies are doing, like Society for Manufacturing Engineers, PMA, Precision Metal Forming Association, ASME, American Society for Mechanical Engineers. So there's also a few societies that have started to provide education around this subject.
Awesome, thank you. Next question. How can I train myself to be an IoT expert? What programming language is used or software?
It's a good question depending on your specialization, right? If you remember the automation pyramid I showed, you got machines, you got SCADA, you got MES, you got ERP, right? Depends where you want to focus. And then you have the analytics layer. So from the data science perspective, for example, I mean, MATLAB is a key tool to get you started. Using languages like Python is also an important tool, open source. Having knowledge of databases like SQL is also important. So it's multifaceted, I would say, depending on where you want to specialize. But in the data science world, having knowledge of databases and data science programming languages will definitely get you started. In addition to the instrumentation side, right? How do I get data out of a machine controller and use OPC, for example? You can go to the Kepware website and you can get a 30-day free trial of Kepware and some fake machines you can play with and get data from the internet and things like that. So feel free to email me, and I could even send you some job descriptions of the people we look for when we're doing hires around data science and so on, and that'll give you a flavor of some of the required skill sets that we look for.
Perfect, thank you. Next question, more of a follow-up to an earlier question. What can be done if the machine is Ethernet capable, but the program is password protected by a company that no longer exists?
Wow, that's a great question. You gotta find a way to hack that password. I mean, there's multiple ways. In this case, potentially a gateway hardware might make sense, but that'll only help you capture machine data. If you're looking for part ID and recipe information that's in the program, and we're unable to access it, and we're unable to break the password, I mean, all I could think of is really re-engineering or recoding the program and coming up with a new recipe. So that's a thought there. But usually, machine data should still be accessible from the Siemens or Allen Bradley or the data blocks that you have, and we can work around that password protection. Usually, we do not need it to capture the machine relevant parameters.
Great, thank you. Next question. In cases of OEM, how is it possible to implement the Industry 4.0 to tracking vendor tools to monitor the maintenance of the tools if a tier 1 supplier has multiple architectures to implement?
It's a good question. I think some OEMs and suppliers have preferred tools actually, and there are some tools out there when it comes to tool management and supplier management. I recall a tool called LiveSource, LiveSource, that you can check out online, and there is many other similar companies, but that is like an OEM and tier supplier tool for managing supplier tools and so on and so forth. I would need to understand the business case a little bit better in order to give you better guidance. You're welcome to email me, but the company LiveSource came to mind when you asked the question.
Awesome, thank you. Next question, what is the role of high performance computing in terms of IoT?
I think it's key. I think there's a move towards the cloud. There's a move towards AWS and Azure as an example. And the cloud storage and capability of HPC is improving. And as we go deeper into AI and go into machine learning and a subset of machine learning, which is called the deep learning, I did not discuss that today. But if we're looking at high performance data like images and videos and high intensity, high storage analysis, HPC is definitely required. It takes more time to train the models. It is more costly. And rather than using CPU, we are using GPUs, graphical processing units. And it's a costly, actually, there's a charge, I think, per second or per minute to get access to GPU servers by the cloud providers. But HPC is definitely a must. The question is always, do you really need it, right? We have to, again, look at the business case. We have to look at the use case, the template, and really understand if there is a need for HPC, or can we just go by with the regular computing capabilities, especially if the application is not mission critical, then HPC may not be required.
Great, thank you. So we only have time for this one last question. They ask, can you tell us more about IoTco? Are you an OEM?
Yeah, very simple, actually. IoTco is a technology provider. IoTco is a consulting, a training, and an analytics organization. We have our own predictive analytics software product, and we provide an end-to-end digital transformation tools. All the tools that I've shown in the presentation today actually can be provided through IoTco, in addition to the strategy and training work. And we focus on the manufacturing sector, automotive, aerospace, industrial, all similar logos that you see here. We're also proud partners of the University of Cincinnati. We do our course working at UC for Industry 4.0. We also bring in talent from UC to support us in all the different practices that we provide. So thank you for the question.
Wonderful. Well, that's all we have for now. Thank you, Mo, for a great presentation, and thank you, attendees, for joining us. We hope you'll return for future webinars. Bye for now.